Welcome to Bunch's classes. Today we are going to understand about the deviation suffered by a reflected ray. So let us see different cases here. ఆ డిఫరెంట్ కేసెస్ అబ్జర్వ్ చేసేటప్పుడు ఫస్ట్ కేసు ఏంటంటే కేస్ ఏ, కీపింగ్ ద ఇన్సిడెంట్ రే ఫిక్స్డ్. If a plane mirror is rotated about an axis in the plane of the mirror through a certain angle, the reflected ray rotates through twice the angle in the same sense. Observe this, in the same sense. So let us understand this. You come here. Here M dash is mirror, plane mirror. This is the way of falling incident ray on the mirror. Incident ray is falling on the mirror with zero angle, it's zero incident angle, and reflected ray also follows the same track. So it traces the same path, incident ray and reflected ray. This is the sense. Let us come to next position. This is figure A, and let us observe what happened in figure B. Actually, this is the position of mirror in previous case. From this position, we have rotated the mirror in this sense, like this. Mirror is rotated with making a theta angle in anti-clockwise direction. So let us observe. Incident ray is falling. Actually, see this. Here, angle MOP is equal to 90 minus theta. Angle MOP. This angle will be, and mirror is rotated theta angle. This angle MOP is 90 minus theta. This angle. Okay? Next angle MOP is 90 minus theta. Then angle PON. Angle PON. This angle will also be theta, which is the incident angle of incidence. Angle of incidence to the new position, rotated position of the mirror. So this will be theta, and angle, this angle you see, you treat it as Q. Angle NOQ is also theta, which is reflected angle. So angle of incidence is equal to angle of reflection. So in both cases it will be theta. So you observe that when mirror is rotated at an angle theta in anti-clockwise direction, previously reflected ray traced the same path. Here reflected ray has moved theta plus theta, 2 theta angle in the same path, in the same sense. When mirror is rotated theta angle, reflected ray which was followed the same path in the previous case has rotated theta plus theta, which is 2 theta, in the same sense, that is anti-clockwise direction. So as shown in the figure, the mirror is rotated through an angle theta. Mirror is rotated through an angle theta in anti-clockwise direction. So the reflected ray rotates through an angle 2 theta in anti-clockwise direction. Here you see reflected ray which was in this sense in the previous case, it traced the same path. Now reflected ray has taken a deviation of 2 theta angle in the same sense, anti-clockwise direction. Okay, understood? So now you pause the video and note the concept along with the figures. this previous case A, in which we fixed the incident, keeping the incident ray fixed, and mirror is rotated at an angle theta. Then we observe that the reflected ray is rotated to theta angle in the same sense. In this case A, this fact is used in many optical instruments such as periscope, sextant, optical lever, etc. In all these optical instruments like periscope, sextant and optical lever, this case A fact is widely used. Next, let us go to case B. In this case, keeping incident ray fixed, if a plane mirror is rotated about an axis perpendicular to the plane of the mirror through a certain angle, the reflected ray does not rotate. What we did here? Keeping incident ray fixed. We did not change the incident ray. But plane mirror is rotated about an axis which is perpendicular to the plane of the mirror. Observe this. We have rotated the mirror about an axis that is perpendicular to the plane of the mirror through a certain angle. Then reflected ray does not rotate. It will not affect anything. Let us observe this case. In this case, you just think that this is a plane mirror. Incident ray is like this. Reflected ray is like this. If we rotate the mirror like this, perpendicular, at an angle perpendicular to the axis, mirror axis, in this way if you rotate, incident ray is incidence at a point, reflected ray will not change. So reflected ray will not affect. The same thing you observe here. This is MM dash mirror. This is incident ray. This is reflected ray, normal. Mirror is rotated in this way. Rotation of mirror about an axis. About normal, keeping incident ray fixed. We did not change the incident ray. As a result of that, reflected ray will not affect anything. Same angle. Reflected ray does not change. This is the fact. Okay. Case B, what it is telling? Keeping the incident ray fixed. If a plane mirror is rotated about an axis perpendicular to the plane of the mirror through a certain angle, the reflected ray does not rotate. Understand these facts and note it. Pause the video and note it. Okay, now let us go to case C. This is third case. If a plane mirror is kept fixed, if a plane mirror is kept fixed, we are not rotating the plane mirror. What we are doing now? And incident ray is rotated. Then reflected ray will rotate in opposite sense by same angle. So reflected ray in this case, we are not rotating the mirror. Mirror is kept fixed. And the incident ray is rotated at a certain angle. But the reflected ray will rotate in opposite sense by the same angle. Let us observe this. M dash is a plane mirror. This is IR1, incident ray 1. This is RR1, reflected ray 1. Incident ray 1, reflected ray 1. And this is normal. When now I did, what I did, incident ray is rotated like this at an angle theta. In which direction? Anti-clockwise direction. This rotation is anti-clockwise direction. What happened to reflected ray? Now reflected ray is rotated in clockwise direction in the same angle, making the same angle. So that we have to observe here. In this figure, incident ray is rotated through an angle theta anti-clockwise. The reflected ray is rotated through an angle theta in clockwise direction. That means this is anti-clock. This will be clockwise direction. That is nothing but opposite sense. Reflected ray is rotated by opposite sense. Remember this point. Pause the video and note the concept. Now, let us consider the fourth case, which is case D. In this case, we are going to observe that if both mirror and the incident ray are rotated. Here, what we are doing? Mirror and incident ray. Both we are rotating. Then what will happen? Then the net deviation suffered by the reflected ray is the algebraic sum of deviation due to each effect. We have to consider the deviation in each single effect. That means, so here what is the net deviation of the reflected ray? That is nothing but delta net. Net deviation is equal to delta 1. What is delta 1? This is the deviation due to rotation of mirror keeping incident ray fixed, plus delta 2. What is this delta 2? This is the deviation due to rotation of incident ray keeping mirror fixed. Here the delta 1 is the deviation due to rotation of mirror keeping incident ray fixed. Delta 2 is the deviation due to rotation of incident ray keeping mirror fixed. These two deviations we have to add. After adding these two deviations separately, we will get the net deviation suffered by the reflected ray. Here one more important thing. Consider the sense of rotation. So, you observe that if incident ray is rotated anti-clockwise or clockwise, whatever it may be, you have to consider the sense of rotation. Generally what we are taking, anti-clockwise rotation, we are taking as positive sense. And clockwise rotation, we are considering as negative sense. So we have to consider these rotation directions, sense of rotation. Anti-clockwise we consider as positive, clockwise we consider as negative. Accordingly, we have to sum up these two deviations. If it is anti-clockwise, consider it as a positive deviation. If it is clockwise direction, consider it as a negative sense. So, keeping in mind all these two types of rotations, you can calculate the net deviation suffered by the reflected ray. So, pause the video and note the content. Now, let us understand the maximum number of times the ray undergoes reflections, including the first one, before it emerges out. So, we have to calculate how many times a ray will be reflected in between two parallel plane mirrors, that we have to calculate. So, here you observe two plane mirrors A and B are arranged parallel to each other. The length of the mirror, each mirror is L. Here it is mentioned. Let the length of mirror be L. the distance between the mirrors is small d. Here an incident ray is incident at an edge point of the first mirror A. Then what happens? It takes many number of reflections. How many times it reflects? That we have to calculate. To understand this, come here. Let us see the same figure. Mirror A, mirror B. Incident ray is fallen at one of the edge points of the first mirror A. Then this incident ray, due to the reflection, it is reflected in this way. Let the angle of incidence be theta. Then this RQ line is dotted line. RQ is normal, and this is reflected ray. RP is reflected ray, and theta will same theta will be the angle of reflection. Okay. Let this distance be x. Now observe the triangle. In triangle PQR. PQR. Observe this triangle. In this triangle, angle PQR is 90 degrees. This is 90 degrees. Right angle triangle. Angle QRP. QRP. Angle of reflection. This is theta. Now let us calculate tan theta. Tan theta is nothing but opposite side by adjacent side. What is theta's opposite side? PQ, and theta's adjacent side is RQ. That is nothing but PQ by QR. PQ is what? X. And what is QR? QR is nothing but the distance between the two mirrors, that is small d. So x by d is the value of tan theta. Then we can calculate x is equal to d tan theta. Okay. Let it be equation 1. Okay. Suppose it takes n number of reflections like this. Incident, after falling the incident ray, n number of reflections were taken place. If there are n number of reflections, then the n for each reflection it is covering a distance of x. Then n into x will be equal to total length of the mirror. Nx is equal to L. From this we can calculate number of reflections. Number of reflections n is equal to L by x. N is equal to L. What is x? From equation 1, x is equal to d tan theta. So n is equal to L by d tan theta. Here you observe, to calculate the number of reflections between two plane mirrors which are arranged parallel to each other, we should know the length of the mirror L and the distance between two mirrors small d and the angle of incidence theta. If you know, you can calculate the number of reflections that were taken place between the two mirrors by using this formula. Understand? Now pause the video and note the concept. Okay, did you note this? Okay. Till now I have explained 4 cases that deviation suffered by a reflected ray, and in this case we have discussed about the maximum number of times the ray undergoes reflections, including the first one before it emerges out. In the next video I will explain about what is real object, what is real image, what is virtual object and what is virtual image. All these things I will explain in the next video. Thank you for watching the video. Like, subscribe and share the video. Thank you.